Let's talk about a beginner level dynamic programming problem today. The problem is climbing stairs, and this is the leetcode problem number 70. I just copied it from here. So the problem is just that if you're climbing a staircase, it takes n steps to reach the top. For example, it is a staircase, and there are in total n number of steps there. Each time you either climb one or two steps. What does it mean? It means you can jump the first step. For example, you are jumping from here or climbing from here. You can jump on these steps, or you can directly jump on these steps. So that's the two way you can climb. Problem is asking in how many distinct ways can you climb to the top. So you need to find out if you want to go from the ground level to this nth level, how many ways we can go there. There are some examples here. You can go ahead and check leetcode. Those examples is leetcode problem number 70. But now let's talk about how can we solve this problem. So the intuition here is if we are at step number 3, from where we can go to the step number 3. We can go from step number 2, stair number 2, because we can jump one step. So we can go from here to here. And again, there is another way from here because we can climb 2 steps at a time. So we can also directly jump from here to here. So that means there are 2 ways to go to step number 3 from stair number 2 and from stair number 1. We don't know how many ways to go to stair number 1 or stair number 2, but we do know now that to go to step number 3, there are at least 2 ways. That is, we can go from stair 2 and we can go from stair 1. So how many total ways to go to step number 3? Can we say that this is the combinations of the number of ways that we can go to step number 2 and we can go to step number 1? Similarly, if you want to go to the nth step, from where we can go to the nth step? We can go to from n-1th stair to the nth stair. And again, we can go from n-2 stair to nth stair. Because as I told earlier, like you can take one step or you can take 2 steps, right? If we somehow know that the number of ways to go to these steps and the number of ways to go to these steps, we can say that the number of ways to go to nth step will be the additions of the number of ways to go to these steps and the number of ways to go to this step. Can you see the sub problem pattern here? So that means if we can solve the problem for n-2 and for n-1, we can solve the problem for n. Similarly, if we can solve the problem for second step and for the first step, we will get the result for the third step. So there is a sub problem structure here, and that is the number one indications that we can use dynamic programming to solve this problem. So what is dynamic programming? Dynamic programming is, if you consider the top-down approach, dynamic programming is nothing but recursion with memoizations. So let's go to the code and see how we can solve this problem with dynamic programming. So here's the code. I'm defining a function dp and taking n as an argument, and I'm returning dpn because n, we're getting n from here. I'm using Python, by the way. Since this is a recursion, we're using some recursion. We need some base cases, which is here. But first discuss this one. So as we have seen that to get the number of ways to the nth step, if we somehow know the number of ways to go to the n-1th step and n-2th step, then the number of ways to reach the nth step will be the addition of those two, right? So we can simply return the sum of these two. Don't worry about how we are going to get the result for this one and this one, because that's the beauty of recursion. So we are calling itself, the function is calling itself, and at some point it will reach these base conditions and it will return the value from there, and then it will build the solutions on top of that base conditions. So if we have the base conditions on the recursions, then we don't need to worry about from where this value is coming. We can think about Almighty God will give us those results. But if you think about that, it will make it easy to reason about it. Here the Almighty is like the base conditions. If you have the base conditions, you will get value from the recursions, right? So simply we can return the dpn minus 1 plus dpn minus 2, and that would be our result. And finally, we're calling dpn. Dynamic programming is recursion with memorizations. Here I'm using Python, so there is a Python decorator called functools.lru cache. It can take care of the memorizations. With memorizations, we can speed up the process. But I won't recommend to directly use these decorators in an interview. Instead of that, we can use a dictionary to work as a memory for us. Let's see an example of that. So here is another example. Instead of using the decorator, I have used a dictionary to store the subproblem, the result of the subproblem. So whenever we have the result of a subproblem, we don't want to do the recursion again. We don't want to calculate the result again. We can just return the value from our memory. So that's how we can reduce the calculations, the number of calculations, or the time complexity. So how can we do that? Let's say we're defining a dictionary called mem, short form of memory. And here is our base conditions. And first we'll check if we have this value, we have the result for argument n in our memory. In that case, we don't want to do the recursion again because we already calculated that value. So we can simply return it from the memory. Otherwise, what we can do, in another examples, we directly return this value, right? But in that case, since we are using our own memoization technique here, we are using our own dictionary, we need to store the value of this result. Res is the short form of result, because we don't want to calculate this again. Next time we need to find out the value for the argument n, we can directly return that value from our memory. So that's why we need to store it in our memory. So first we are storing it on our memory, and then we are returning the result. So that's how we can improve the time complexity of this problem using memorizations. I hope you like this video. If you think this video is helpful, it helped you to understand this problem, and if you have learned something new today, please like, share, and subscribe to my channel. Thank you so much. I will see you in the next video.